Hi my dear students, welcome back to our amazing YouTube channel of Brilliant Katha. This is the fourth video lecture in our JEE Mantra series, and in this lecture we will be revising vector, 3D and probability. We'll start with vectors first. So coming to vectors, first let's define what is a vector. In simple words, a physical quantity which has both magnitude and direction is called as a vector. As you know, there are two types of physical quantities, vectors and scalars. Scalars will only be having magnitude and no direction, but vectors will be having both magnitude and direction. So in mathematical terminology, a vector is simply defined as a directed line segment. That means a line segment, generally a line segment will be having some magnitude. If that line segment will also be having some direction, let's say AB is a line segment directed from A to B, a line segment AB, we are taking the direction from A to B, then such line segment is called as directed line segment, and each directed line segment is a vector. So according to mathematical terminology, vector is simply defined as a directed line segment. Then you will understand everything, friends. Okay, so let's consider a line segment AB. Let's consider a line segment AB. A line segment AB is said to be a directed line segment if it has some direction. Let's say the direction of AB from A to B. Then this particular directed line segment is called as vector. We denote it as AB bar. So if AB bar is a vector, then A is said to be initial point, point B is said to be terminal point or final point, and length of this line segment AB, is modulus of AB bar, modulus of the vector. AB bar is nothing but length of the line segment, length of line segment AB bar, length of line segment AB bar. We generally denote it as mod AB bar or just simply AB. Okay, so AB bar is a directed line segment. Now every line segment is derived from a source, is derived from a line. Let's say it is derived from a line L. There is one line L. From this line, a portion is taken from that line, and that portion, if we call it as line segment AB, then this line L is called as source, or we say support. Source or support. So this line L is called as source of the line, source of the vector AB bar, or source of the directed line segment AB bar. For every vector there will be some source. And from each source, infinite number of line segments can be taken. That means from every source, from every support, infinite number of vectors can be drawn. Next, types of vectors, different types of vectors. We start with null vector. Null vector means a vector with no magnitude, but has some direction. Let's say point, or we say dot is called as null vector. Generally null vector is denoted as O bar. Every null vector will be having magnitude 0. Magnitude of the null vector will be 0. We say it has some specific direction. It has some direction, but in general null vector doesn't have any specific direction. Next, unit vector. A vector which is having magnitude 1 unit. Let's say A bar be any vector, then a unit vector in the direction of A bar, A bar is denoted as A cap, friends. A cap denotes unit vector in the direction of A bar. And how you get it? When you divide a vector by its modulus or magnitude. When you divide any vector by its magnitude, then such vector is called as unit vector. Next, parallel vectors. collinear vectors. In complete vectors, we will be going with only free vectors. Free vectors means they are easy to translate. Let's say this is some AB bar. A bar be any vector. Then this can be translated to any place without changing its direction and magnitude. See, A bar. This can also be shifted here. This can also be shifted here. This can also be shifted here. So all the vectors which we are discussing in this complete vector and 3D are only free vectors. Okay, vectors are free vectors. So we can translate any vector. So that is the reason whether you say parallel vectors or collinear vectors, both gives the same. Because if A bar and B bar are any two parallel vectors, as we can translate this vector, see, after some instance we can make them as collinear vectors. So parallel vector or collinear vectors, there won't be any difference. Now parallel vectors or collinear vectors means, in simple words, if they are from the same source or parallel source. Two vectors, if they are from the same source or parallel source, such vectors are called as collinear. Let's say A bar. This is one A bar. Another vector B bar. So A bar and B bar are having parallel support. Then these two vectors are called collinear or parallel vectors. Let's say another vector C bar. Another vector C bar also has some parallel support, but in the opposite direction. Even these three are parallel or collinear vectors. But in parallel vectors, there are two classifications: like vectors and unlike vectors. Now, like vectors means parallel vectors which are in the same direction are called like vectors, and parallel vectors which are in the opposite direction. So A bar and B bar are like vectors, friends. Whereas B bar and C bar are unlike vectors. And most important thing, if two vectors A bar and B bar are collinear, then one we can write a scalar times the other. A bar is equals to lambda times B bar. We can express A bar as lambda times B bar. If this lambda is positive, then they will be in the same direction. If lambda negative, then they will be in opposite direction. If lambda positive, we call them as like vectors. If lambda negative, then we call them as unlike vectors. Next, one more thing. If A bar and B bar are non-collinear vectors, and if x into A bar plus y into B bar is equals to 0, then it happens only in one case, which implies x is equals to y is equals to 0. You can't express one vector as the scalar times other vector if the given two vectors are not collinear. If they are collinear, only then you can express. If they are not collinear, then you can't express. Still, if you can express, that happens only in one case, when the scalar are 0. When the two scalars are 0, then only we can express the given two non-collinear vectors as x into A bar plus y into B bar is equals to 0. Next, apart from that, in types of vectors, we have co-initial vectors. Co-initial vectors means vectors having same initial point. A bar, B bar, C bar. Next, co-terminal vectors. Vectors having same terminal point. Next, coplanar vectors. Vectors which lie on the same plane. Let's say some plane. A bar, B bar. A bar is one vector, B bar is another vector, C bar another vector. All these vectors, if they are belonging to the same plane, then such vectors we call them as coplanar vectors. Two vectors will always be coplanar. Why? Because all these are free vectors now. We can translate them. See, this is one vector and this is one vector. These two vectors, though in the beginning they are not belonging to the same plane, we can translate this vector. We can translate this vector without changing its direction and magnitude. So now you see, these two are coplanar vectors. So two free vectors will always be coplanar. In our complete vectors, if we are discussing about a vector, that vector is a free vector. So two vector will always be coplanar. To decide whether they are coplanar or not, then we need at least one more vector. Next, triangle law or parallelogram law of vectors. Let's say in a triangle, if one side is A bar, other side is B bar, then the resultant of these two vectors is given by the third side. Triangle law of vector says that if two sides of a triangle are given by A bar and B bar, then the resultant of these two vectors is given by the third side, and we say A bar plus B bar is equals to C bar. That's it, friends. Triangle law of vector states that in any triangle, if two vectors are given by A bar and B bar, then the third side is the resultant of these two vectors, that is A bar plus B bar is equals to C bar. Next, parallelogram law of vectors. Parallelogram law of vectors is also derived from triangle law of vectors only. So according to parallelogram law of vectors, let's say if A bar and B bar are any two adjacent sides of a parallelogram, A bar and B bar are any two adjacent sides of a parallelogram. Next, if this is A bar, this will also be A bar, friends, because in parallelogram opposite sides will be equal and parallel. If this is B bar, and then this will also be B bar. Now, if you see this, friends, A bar, B bar, the diagonal, let's say some D1 bar. Now D1 bar is the resultant of A bar and B bar. So from triangle law of vectors, D1 bar is equals to A bar plus B bar. A bar plus B bar. Okay, na? Next, another vector we need. Let's see this. One more diagonal is some D2 bar. Let's say this is D2 bar. Now D2 bar is the resultant of A bar and this will be minus B bar, friends. D2 bar is the resultant of A bar and minus B bar. So D2 bar is equals to A bar minus B bar. So that means if two adjacent sides of a parallelogram are given by A bar and B bar, then the two diagonals can be formed by parallelogram left vectors, which is nothing but triangle law of vectors only. And those two diagonals of the parallelogram with adjacent sides A bar and B bar are A bar plus B bar and A bar minus B bar. We use this concept in finding angular bisectors. So just remember this. The thing is, if A bar and B bar are any two adjacent sides of a parallelogram, then their diagonals will be, one will be A bar plus B bar, one will be A bar minus B bar, or B bar plus A bar, B bar minus A bar. Anything is fine. Whereas in triangle law of vectors, resultant of two vectors is given by the third side, and A bar plus B bar is equals to C bar. Next, position vector section formula. See, friends, position vector and section formula. Let's say, let's consider OA bar, let capital A be any point, then position vector of point A is nothing but, if we join this point A to origin, then we are getting a line segment. OA. OA bar is the directed line segment. Now OA, the line segment OA has some specific direction from O to A. So this OA bar is position vector of point A, friends. Position vector of point A. Position vector of point A. So for every point, if we join that point to origin, then we will be getting position vector of that particular point. Let's say another point B we have. Then this is OB bar. We call OB bar is the position vector of point B. Now let's say this is BA bar. So by using triangle law of vectors, again in this case, see, OA bar is the resultant of OB bar and BA bar. So OA bar is equals to OB bar plus BA bar. From here, BA bar is equals to OA bar minus OB bar. We say BA bar is equals to OA bar minus OB bar. At the same time, AB bar is equals to OB bar minus OA bar. And this is what we say position vector of the given point. Next, section formula. By using section formula, same like in 2D, let's say there are 2 points capital A comma capital B. The position vector of point A is A bar. Position vector means OA bar is A bar. Position vector of point B is B bar. Let's say there is some point capital R which is dividing AB in the ratio M is to N. M is to N. Hence, the position vector of point R, that is OR bar, will be equals to M into B bar plus N into A bar divided by M plus N. If this is internal division. If this is internal division. Next, if this is external division. If external division, in second case we put M into B bar minus N into A bar divided by M minus N if it is external division. Next, midpoint. Midpoint R bar, or we say OR bar. Where R bar is, I am taking R bar as the position vector of point R bar. R bar is equals to, if it is midpoint, then we write A bar plus B bar by 2. So midpoint formula, section formula, in section formula, internal division, external division, all we can relate to 2D and get it. Just only bar will be extra. Scalar product of two vectors. Let's say A bar and B bar are any two vectors, friends. A bar and B bar are any two vectors such that angle between them is some theta. Then scalar product of these two vectors is denoted as A bar dot B bar. A bar dot B bar, which is given by mod A into mod B into cosine of the angle between them, that is cos theta. See this, friends. In the right hand side of A bar dot B bar, mod A, which is scalar, mod B is scalar, cos theta is also scalar. So as the right hand side of complete A bar dot B bar is only scalar, so we call this as scalar product, or we say dot product. We can also call this as dot product of the given two vectors. So A bar dot, the resultant of dot product is always a scalar, and dot product of two vectors is always commutative, that is A bar dot B bar is equals to B bar dot A bar. Next, when will be dot product maximum? A bar dot B bar will be maximum, friends, will be maximum if theta is equals to 0. That means if they are like vectors. So what will be that? And that too, this is equals to how much? Mod A into mod B. And A bar dot B bar will be minimum when they are unlike vectors, that is theta is equals to 180. So in that case, we get minus times mod A bar into mod B bar. If theta is equals to 90, that means if A bar and B bar are perpendicular, if A bar perpendicular to B bar, then A bar dot B bar will be equals to 0. Next, one more thing, friends. From here, we can also find the angle between given two vectors. If theta is the angle between given two vectors, from here, cos theta is equals to A bar dot B bar divided by mod A into mod B. Mod A into mod B. See, if they are perpendicular, then A bar dot B bar will be equals to 0. If they are parallel, A bar can be expressed some lambda times other. A bar is equals to some lambda times B bar. Okay. Next, projection and component. Projection and component. This is one most important application of scalar product. Let's consider two vectors, friends. Say A bar, another vector B bar. A bar, B bar. Let's see this. A bar, B bar are any two vectors with angle, with theta be the angle between them. Next, if we draw a perpendicular from B bar to A bar, if we draw a perpendicular from B bar to A bar, let's say this is OB, point A, and this perpendicular intersects A at M. Okay, so this OM, friends, this OM is called as projection of B bar on A bar. This OM, length, OM, this OM, length of OM, length of the line segment OM is called as OM is called as projection of B bar on A bar, and this OM is equals to, formula to remember is also very simple. Projection of B bar on A bar is nothing, whether it is B bar on A bar or A bar on B bar, numerator will always be A bar dot B bar. Whether it is A bar, projection of A bar on B bar or B bar on A bar, numerator is always A bar dot B bar. Now denominator, only denominator will be differed. Projection of B bar on A bar, so you divide with mod of A bar, friends. That's it. Understood? Next, this is regarding projection. Next we go with component. Component of B bar along A bar. Component of B bar along A bar, and this we call it as OM bar. This we call it as OM bar. To get OM bar, friends, it is just mod of OM bar into along A bar. Now we multiply with A cap. Along A bar, now we just multiply with A cap. So OM bar is already this length. OM bar is nothing but length of the line segment OM, and that is what already equals to A bar dot B bar divided by mod A into A cap. So this is how we get projection and component. Projection and component are the two most important applications of dot product, friends. Clear? Apart from that, we also have some important relations in scalar product. That is, number one, A bar dot B bar, already I said commutative. So A bar dot B bar is equals to B bar dot A bar. Next, scalar component of something. See, let's say if this A bar dot B bar, lambda A bar dot B bar is also equals to A bar dot lambda B bar, we can just throw this lambda out and we write A bar dot B bar. Next, other important applications. A bar dot A bar, friends, whenever you come across dot product of two vectors, A bar dot B bar is equals to mod A bar, mod A whole square. This is also equals to A square. Representation, whether you see A square or mod A whole square or A bar dot A bar, is always, all the three are same. Next, mod of A bar plus B bar whole square. If I say, this is nothing but A bar plus B bar dot A bar plus B bar. So this we can write it as A bar dot B bar is A square plus B square plus 2 times of A bar dot B bar it is. So finally we can write it as A mod A square plus mod B square plus 2 times of mod A into mod B into cos theta, friends. Clear? So from here we can say mod of A bar plus B bar will be equals to square root of mod A whole square plus mod B whole square plus 2 times of mod A into mod B into cos theta. In the same way, mod of A bar minus B bar will be mod A square plus mod B square minus 2 times mod A bar B bar into cos theta. Only if it is plus, we write plus here. If it is minus, we write minus here. These two are the most important. Generally, frequently we come across. Even for 3 vectors we have. If it is 3 vectors, let's say A bar plus B bar plus C bar modulus whole square, mod of this whole square, if I write, then this we can write it as A bar plus B bar plus C bar dot A bar plus B bar plus C bar. So this we can write it as A bar square plus B bar square plus C bar square plus 2 times of A bar dot B bar dot C bar plus C bar dot A bar. If alpha is the angle between A bar and B bar, then 2e mod A mod B cos alpha, 2 mod B mod C some cos beta, mod C mod A some cos gamma. So we use this formula also. These two formulae, these two and this one, very important formulae. Next, we go with the properties of scalar product. Just now we have seen all the properties of scalar product. Next, vector product. Now coming to vector product, friends, same like that. If A bar and B bar are any two vectors, A bar and B bar are any two vectors with angle between them is some theta. Okay. Now A bar cross B bar, cross product of two vectors A bar and B bar is A bar cross B bar, is equals to A bar cross B bar is equals to mod A into mod B into sine of the angle between them. As theta is the angle between them, it is sine theta into one most important, that is n cap. Friends, what is this n cap? N cap is the unit vector which is perpendicular to the plane of A bar and B bar, which is perpendicular to the plane of A bar and B bar. And one more thing, cross product of two vectors will always be a vector, friends. That is the reason we call it as vector product. Now, the direction of the resultant is given by right hand thumb rule. See, we are multiplying A bar and B bar, no? A bar cross B bar. A bar, from A bar you are going to B bar. A bar cross B bar is equals to, then this thumb indicates the direction of A bar and B bar. A bar cross B bar. So, this direction will be our A bar cross B bar. So, A bar cross B bar will be in the direction of n cap. Clear? A bar cross B bar will always be a vector, friends. A bar cross B bar is always a vector. Next, if theta is equals to 0, cross product of two vectors will be 0. A bar cross B bar will be equals to 0 bar. Clear? Next, that means if theta is 0, A bar cross B bar will be minimum. Next, if they are either collinear, I mean either like vectors or unlike vectors or parallel vectors, then it will be minimum. If they are perpendicular, if theta is equals to pi by 2, that means vector A bar perpendicular to B bar, in this case A bar cross B bar will be maximum, and that value is equals to mod A mod B. If it is modulus of A bar cross B bar will always be equals to maximum when theta is equals to pi by 2. That is, if the given two vectors are perpendicular, then we write it as maximum. Next, some properties of vector product or applications of vector product which are very important. Properties, or we say applications. Number one is vector product of two vectors is not commutative. That is, A bar cross B bar is equals to minus of B bar cross A bar. A bar cross B bar will be equals to minus of B bar cross A bar. And how do we find, in general, how do we find cross product, friends? Cross product is, suppose if A bar is equals to some x1i plus x2j plus x3k, B bar is equals to y1i y2j plus y3k. Now A bar cross B bar will be equals to modulus of determinant of I, j, k. We know how to expand determinant. First we have A bar, then components of A bar x1, x2, x3, y1, y2, y3. Then if we expand determinant, we get cross product of these two vectors. Next, how do we get dot product, ma? See, A bar dot B bar will be, I am giving it here itself. A bar dot B bar will be x1, x2 plus y1, y2 plus z1, z2. Next, important applications of cross product that we have are, major applications of cross product are areas, friends. Now coming to areas, number one, area of a triangle with two sides given, friends. If two sides given, then we write it as area of this particular triangle is half times mod of A bar cross B bar. Half of mod of A bar cross B bar. Number two, area of parallelogram with adjacent sides given. A bar and B bar are adjacent sides of parallelogram. Then area of this parallelogram, no half, it will be only mod of A bar cross B bar. If for the same parallelogram, instead of sides, if they give you diagonals, friends, let's say P bar and Q bar are the diagonals of parallelogram, then area of parallelogram with diagonals will be half times P bar cross Q bar. And not only parallelogram, any quadrilateral, area of any quadrilateral, with diagonals P bar comma Q bar given is equals to half times mod of P bar cross Q bar. Half of mod of P bar cross Q bar. So these are the different applications. And one more thing, we also have, suppose if vertices of a triangle given, if vertices of a triangle given, let's say ABC are the three vertices of triangle. A of A bar is vertex, position vector of point A, position vector of point B, position vector of point C. These three are vertices. In this case, these two are sides. So if vertices are given, then area of the triangle is equals to half of mod A bar cross B bar plus B bar cross C bar plus C bar cross A bar. So these are the important formulae from applications of cross product. So that is regarding vectors. Now we enter into 3D, friends. Now coming to 3D, three-dimensional geometry, where we discuss about space. So in 3D, we'll be having three mutually perpendicular axes called x-axis, y-axis, z-axis, x, y, z-axis. Any point in space is represented by an ordered triplet. Let's say P has coordinates x, y, z. P has coordinates x, y, z. So any point in space is given by an ordered triplet. In 2D, ordered pair, here ordered triplet. Next, apart from that, we will be having three planes. What are they? Equation of xy plane is z is equals to 0. Equation of yz plane will be x is equals to 0, because every point on yz plane will be having x coordinate 0. And in the same way, equation of xy ho gaya, yz ho gaya, xz plane is y is equals to 0. Next, suppose if we take a point on P, we have point P in space having coordinates x, y, z. Now, if I draw a perpendicular from point P to x-axis, let's say it intersects at some M. So M will be having coordinates x, 0, 0. Now, the distance from any point, distance from P to x-axis will be square root of y square plus z square. Clear? Under root of x minus x whole square plus y minus 0 whole square plus z minus 0 whole square. And now distance from P to y-axis, under root of P2 from y-axis will be x square plus z square. Distance from point P to z-axis, root x square plus y square. Next, if we have any 2 points in the space, friends, let's say P of x1, y1, z1 and Q of x2, y2, z2 are any 2 points in the space, then distance between them, same like 2D only, distance between them, that is PQ is equals to square root of distance formula, x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. Next, direction cosines and direction ratios, which is one important topic among 3D. We start actually 3D from here. Let's say P has some coordinates x, y, z, friends. P has coordinates x, y, z. So if we join this line segment to origin, then we get OP. OP bar is any line segment, or OP is any line segment. Now, if this OP makes some angles alpha with x-axis, beta with y-axis, and gamma with z-axis. Yeah, alpha, beta, gamma are the angles made by OP with x, y, z axis respectively. So if alpha, beta, gamma are the angles made by OP, a line OP or line segment OP with x, y, z axis respectively, then friends, we curve first one. Number one, alpha, beta, gamma are called as direction angles. Direction angles of line OP. Of line segment OP or line which is passing through OP. Anything. Both are same. Next, if alpha, beta, gamma are direction angles, cos alpha, cos beta, cos gamma, these three are called direction cosines. We simply call it as DCEs of the line. DCs of the line OP. Line OP or line passing through OP. Anything is same. If in general, we also denote direction cosines as LMN, friends. We denote cos alpha as L, cos beta as M, and cos gamma as N. So if cos alpha, cos beta, cos gamma are the direction cosines of a line, one important point is sum of the squares of direction cosines will always be 1. So cos square alpha plus cos square beta plus cos square gamma is equals to 1. That is L square plus M square plus N square is equals to 1 if L comma M comma N are the DCs of any line. If L, M, N are DCs of any line, then sum of the squares will always be equals to 1. Next, direction ratios, we just call it as DRs. Now coming to DRs, friends, if L comma M comma N are DCs of a line, then A comma B comma C are DRs if only A by L is equals to B by M is equals to C by N. That means all the proportional values to DCs are called DRs, friends. All the proportional values to DCs are called DRs. Very simple. If LMN are DCs of a line, then any values which are proportional to LMN are called DRs. We call it as direction ratios. Next, if 2 points are given, if P of x1, y1, z1, Q of x2, y2, z2 are any 2 points passing through a line, we have a line which is passing through points P comma Q. Then number 1, DRs of this line are, DRs of line PQ are x2 minus x1 comma y2 minus y1 comma z2 minus z1. If DRs known, then DCs will be, DCs of line PQ bar will be, we divide x2 minus x1, we divide each DRs with the mod of, that means length of the line segment PQ. If PQ denotes length of the line segment, then x2 minus x1 divided by PQ, y2 minus y1 divided by PQ, z2 minus z1 divided by PQ gives the DCs of that particular line. Next, one more important thing. If line 1 has DRs A1, B1, C1, line 2 has DRs A2, B2, C2, then angle between them will be cos theta will be equals to A1A2 plus B1B2 plus C1C2 divided by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. So this is how we find the angle between two lines, friends. Now, number 1, if lines are parallel, then their DRs will be proportional. That is A1 by A2 is equals to B1 by B2 is equals to C1 by C2. Number 2, if lines are perpendicular, then numerator will be equals to 0. So A1A2 plus B1B2 plus C1C2 is equals to 0. Clear? Next, equation of line in both the forms, vector form and Cartesian form. We have two different equations of line, friends. Number 1, if the line is passing through 2 points, 2 points form, we say. In 2 points form, in general, If the line is passing through A bar and B bar, if line is passing through 2 points A bar and B bar, then we consider R bar any variable point on this line. So R bar, vector equation of a line which is passing through 2 points having position vectors A bar and B bar is equals to R bar is equals to A bar plus lambda times B bar minus A bar. This is the vector equation of a line passing through 2 points having position vectors A bar comma B bar. Number 2, this is 2 points form. Number 2, passing through point A bar and given parallel vector parallel to some vector B bar, parallel to another vector B bar. In this case, see, passing through a point A bar and parallel to another vector B bar. Then in this case, equation of this line is A bar is equals to A bar plus lambda times B bar. Always remember, friends, this is the place where we write point it is passing through, and this is the place we write support. Point, support. Clear? So these are the two different forms of a line, equation of a line in vector form. Whereas in Cartesian form, I hope you remember symmetric form from two-dimensional. X minus x1 by cos theta is equals to y minus y1 by sin theta is equals to r, which is equivalent form to that. And in the same way, number 1 we go with the 2 points form. 2 points form. Equation of a line which is passing through 2 points P of x1, y1, z1 and Q of x2, y2, z2. Equation of a line which is passing through 2 points P of x1, y1, z1 and Q of x2, y2, z2 is x minus x1 divided by x2 minus x1 is equals to y minus y1 divided by y2 minus y1 is equals to z minus z1 divided by z2 minus z1. This is 2 points form, friend. Okay. Next, number 2 is passing through point. They give passing through point P of x1, y1, z1. Previous case they have given parallel. That means and having drs some a, b, c. The required equation of line is see, friends, x minus x1. Numerators will be same, only denominators. Here, if 2 points where the line is passing through are given, then drs will be x2 minus x1, y2 minus y1, z2 minus z1. That means in this case they have given already. So x minus x1 in place of x2 minus x1 we put a is equals to y minus y1 divided by b is equals to z minus z1 divided by c. These two are the different forms of line in both vector form and Cartesian form. A student should able to convert from vector to Cartesian and Cartesian to vector in just no time. Next. So this is regarding equation. Next, angle between two lines, friends. How do we get angle between two lines? Just now in the beginning itself we said, if line 1 has drs A1, B1, C1, line 2 has drs A2, B2, C2, if theta is the angle, between L1 and L2, theta is the angle between L1 and L2, theta is the angle between L1 and L2, then cos theta is equals to A1 A2 plus B1 B2 plus C1 C2 whole divided by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. Already I discussed, friends, if they are parallel, if L1 parallel to L2, then drs will be proportional, implies A1 by A2 is equals to B1 by B2 is equals to C1 by C2, and if L1 perpendicular to L2, then we write A1 A2 plus B1 B2 plus C1 C2 is equals to 0. Next, angle bisectors. Angle bisectors. Better we write it in only vector form, friends. We write it in only vector form. That will be easy. In case of angle bisectors, let's say some two lines. There are two lines. R bar is equals to A bar plus some lambda P bar. Another line is R bar is equals to A bar plus lambda Q bar. Why I am writing A bar means A bar is the point of intersection of these two lines, friends. If A bar is point of intersection of two lines, then two lines are R bar is equals to A bar plus lambda P bar, A bar plus lambda Q bar. So now what are the two bisectors? These two are the bisectors, B1, B2. These two are lines L1 and L2. B1, why two bisectors? Because there will be one acute angle bisector, other will be obtuse angle bisector. So in this case, what we do, friends, do understand this. If this line equation is R bar is equals to A bar plus lambda times P bar, that means this line will be having a support P bar. So what I am doing from here, I'll consider a unit vector P cap. Okay, let P cap be unit vector. Now, if this line has some Q bar, so definitely Q cap will also be in this direction, and I am considering Q cap one unit vector. Okay. Now I would like to construct one square or even parallelogram. Anything is fine. Parallelogram. I would like to construct one parallelogram. Now see this, friends. P bar, Q bar. This forms some A, B, C. This forms a parallelogram. If OA bar and OC bar are two adjacent sides of a parallelogram, then this becomes now diagonal, which is P cap plus Q cap. P cap plus Q cap. That means for B1 bar, for the line B1, it is passing through point A bar and has support P cap plus Q cap. So we can get the equation. Therefore, by equation of bisector, B1 is nothing but R bar is equals to passing through point A bar plus lambda times P cap plus Q cap. In the same way, for this, the support will be P cap minus Q cap. So equation of second bisector B2 is equals to R bar A bar plus some mu times P cap minus Q cap. No need of taking lambda and mu. You can even take some ST, anything. So this is the case where point of intersection is given, ma. If the lines are passing through point of intersection A, sometimes they won't give you point of intersection. In that case, what you do? First you find the point of intersection, then express the lines in this form and then write it in this form. Clear? This is the most simplest thing. Next, skew lines and shortest distance. In simple words, two lines which belong to different planes are called skew lines, friends. They neither intersect nor parallel. Okay. Now, two lines which belong to different planes are called skew lines. The most important thing from skew lines is shortest distance. Let's say R bar is equals to some A bar, A1 bar plus lambda times P1 bar or P bar. Lambda times P bar, and R bar is equals to A2 bar plus some mu times Q bar are any two skew lines. Then shortest distance between them. If D denotes shortest distance, process is so simple, friends. We find the difference of A1 and A2, that is A2 bar minus A1 bar dot P bar cross Q bar. We take mod of this because it can be positive, it can be negative. Distance should never be positive, never be negative, no? So that's why we take modulus whole divided by modulus of P bar cross Q bar, friends. This is how we find the distance between given two lines, given two skew lines, shortest distance. And most important thing, friends, see, if lines are coplanar, if two lines are coplanar, then that means they can only be either parallel are intersecting, correct? Two coplanar lines can either be parallel or intersecting. See, if two coplanar lines are parallel, then their DRs are proportional. DRs will be proportional. DRs will be proportional. If they are intersecting, we equate this numerator to 0, Very, very important. To show that given two coplanar lines intersecting, friends, mark this again. To show the given two coplanar lines are intersecting, we equate the shortest distance to 0. That is A2 bar minus A1 bar dot P bar cross Q bar is equals to 0. If this value is equals to 0, then the given two lines will be intersecting. If shortest distance between two skew lines is 0, that means they are intersecting lines only. So sometimes they ask us to prove that they are intersecting, or to prove the given lines are coplanar, first we check parallel. Checking parallel is so simple. If their DRs are proportional, then they are parallel. If they are not parallel, they can be intersecting. So if in case of intersecting, we just do A2 bar minus A1 bar dot P bar cross Q bar is equals to 0. Two coplanar lines can only be parallel or only be intersecting. Next, parallel lines and their shortest distance. Same case like before. R bar is equals to A bar plus some lambda P bar, A1 bar plus lambda P bar. R bar is equals to A2 bar plus some mu P bar. Because if they are parallel, they will be having same support. These two are two parallel lines. So in case of parallel lines, friends, in case of parallel lines, distance between two parallel lines is equals to, same case like before, A2 bar minus A1 bar. There we did dot, here cross P bar, and modulus of this divided by mod P bar. Modulus of A2 cross product of A2 bar minus A1 bar and P bar divided by mod P bar. This is the distance between two parallel lines. So with that we are done with complete 3D. Now we'll start revising probability. Now coming to probability, friends, first we'll go with basic terminologies or basic definitions from probability, starting with random experiment. We know what is a random experiment. Random experiment means an experiment which results in outcomes which are known to us beforehand. Throwing a dice, tossing a coin, all these are random experiment. Sample space means the set of all possible outcomes of a random experiment. Heads and tails, the set of H comma T will be the sample space when we toss a coin. Set of 1, 2, 3, 4, 5, 6 will be the sample space when we throw a dice. Next, event, a subset of sample space. Getting a number which is less than 3 is our event. So less than 3 means either you can get 1 or 2. Set of 1 comma 2 is our event. This 1 comma 2 is subset of 1, 2, 3, 4, 5, 6. So any set which is subset of sample space is called as event. Complement of an event means when you subtract it from universal set. Not A. In simple words, let's A is any event, not A means complement of it. Simple event, compound event, equally likely events, all these things we discussed, friends. Equally likely means equal chances of occurring. Set of 1, 2, 3, 4, 5, 6, we have 6 elements in sample space. Now probability of chances of occurring 1, chances of occurring 2, chances of occurring 3, 4, 5, 6 are all same. So such events are called as equally likely outcomes. Next, these two are very important. Mutually likely and exhaustive system of events. Mutually likely, mutually exhaustive events or disjoint or incompatible events means if two events are said to be mutually exclusive, if and only if the occurrence of one rejects the occurrence of the other. Clear? That means if their intersection is null set, in terms of disjoint sets, if their intersection is null set, that means they both together won't occur. Let's say E1 denotes probability of getting a prime number. E1 denotes probability of getting a prime number when we throw dice. E2 denotes probability of getting a composite number when we throw dice. If E1 occurs, E2 will never occur. If E2 occurs, E1 never occur. So such events are called as mutually exclusive events. Their intersection will always be a null set. Next, exhaustive system of events means their union will be equals to sample space. E1, E2, E3 are if these three events are said to be exhaustive system, then their union will be complete universal set, whereas in first case mutually exclusive, their intersection will be a null set. Next, classical definition of probability. This is what we keep on discussing since grade 10. The probability of occurrence of an event E is denoted as is equals to the ratio of number of favorable outcomes in favor of E divided by total number of outcomes. That what I did is, friends, let M denotes, what we did is, let M denotes number of favorable outcomes to event E, and N denotes number of unfavorable outcomes to event E. So now total number of outcomes will be now is equals to M plus N. Total number of outcomes will be M plus N. Now see this, friends. So probability of occurrence of an event E is denoted as P of E, and P of E is equals to number of favorable outcomes divided by total number of outcomes, that is M by M plus N. In this case, there are two most important things that I need to define is, one is odds in favor of E and odds against event E. Odds in favor of an event E, odds against event E. Odds in favor of an event E is nothing but favorable by unfavorable, friends. Whereas odds against event E is unfavorable by favorable. These two are very important. We have good questions based on this in previous year. Next, conditional probability. In conditional probability, the probability of occurrence of A, when already the event B has already been occurred. So that is denoted as P of A given B, and P of A given B is equals to P of A intersection B divided by P of B. I proved it in our already in regular session in class itself. I proved it, friends. How do we prove it? Suppose let's say Venn diagram, sample space S, set A, set B, or event A, event B. When you know B has already been occurred, that means this place has already occurred. So which portion P of A given B means probability of occurrence of A when B has already occurred. So when B has already occurred, which portion, how much portion of A has been occurred now? This is nothing but N of A intersection B divided by sample space for that will be N of B. Okay? Are you getting me, friends? N of A intersection B divided by N of B. So if I divide with N of S both numerator and denominator, then I get P of A intersection B divided by P of B. So the probability of occurrence of an event A, when you know that B has already occurred, we call it as conditional probability, and P of A given B is equals to P of A intersection B divided by P of B. Next, independent events. Two events are said to be independent if occurrence or non-occurrence of one event won't affect the occurrence or non-occurrence of the other event. Very simple. If A and B are any two independent events, then probability of P of A intersection B will be equals to P of A into P of B. P of A intersection B is equals to P of A into P of B. Next, if A and B are independent, then A complement B are independent, A and B complement are independent, A complement and B complement are also independent. In same case, we have it for three events also. If A, B, C, A comma B comma C, three events independent, then we write P of A intersection B intersection C is equals to P of A into P of B into P of C. Next, total probability theorem. Coming to total probability theorem, friends, first in this case we have considered B1, B2, B3 and so on, Bn, n mutually exclusive and exhaustive events. First, exclusive event means there exists no common. See, all are disjoint sets. Next, exhaustive events means the union of them is sample space. Okay, B1, B2, B3 and so on, Bn are n mutually exclusive events, exclusive and exhaustive system of events. Let A be another event which is associated to the same random experiment having sample space, yes, then probability of the occurrence of event A is nothing but, see, A will be occurred. In simple words, we can just prove it by n of A is equals to n of A intersection B1, yeah, plus n of A intersection B2 and so on, n of A intersection Bn. Now if we divide with n of S, then P of A is equals to probability of A intersection B1 plus P of A intersection B2 plus P of A intersection Bn, friends. Now if we change it to, if we change by using, we already know P of A given B1 is equals to, P of A given B1 is equals to P of A intersection B1 divided by P of B1. So P of A intersection B1, from here we can write this as P of B1 into P of A given B1. P of B1 into P of A given B1 is equals to P of A intersection B1. So if we substitute this, then finally we get P of A is equals to P of A is equals to P of B1 into P of A given B1 plus P of B2 into P of A given B2 plus P of B3 into A given B3 and so on. That means P of BI into P of A given BI sigma I equals to where to where? 1 to n sigma P of BI into P of A given BI is nothing but probability of the occurrence of event A, friends. Clear? And this theorem is called as total probability. Total probability, if you know total probability, then we can able to get Bayes theorem also, because in Bayes theorem this will be denominator. This will be denominator, and among all of them one portion of this will be in the numerator. That's it. This becomes sample space and one among this will be an event. That's it. So coming to Bayes theorem, now in Bayes theorem, total probability we have seen probability of occurrence of A. In Bayes theorem, what is the probability of occurrence of A when B1 is occurred? In that way, are you getting me? So in that case, P of BI given A will be equals to one among them, P of that BI into P of A given BI divided by P of A. Clear? Or in simple words, by using conditional probability, P of BI given A is equals to P of BI intersection A divided by P of A. When A has already been occurred, what is the occurrence of BI? When A has already been occurred, what is the occurrence of BI? What is the occurrence of B1 or B2 or B3? So then if B1 is asked, they have asked B1, then B1 intersection A divided by P of A. Denominator will always be P of A, and one portion of P of A will be in the numerator. This is what we say Bayes theorem, friends. Next, probability distribution. In probability distribution, we will be having a random variable. Let's say we denote random variable with some x. If x denotes random variable takes some variables. Let's say suppose if there are 15 apples. Now what we are doing, we are in that 15 apples, a box contains 15 apples, friends. In that let's say 4 apples are rotten and 11 are good. 11 apples are good. This is the case we have. Now what we are doing is, we are drawing 4 apples out of that particular box. 4 apples from that box. Now, if x denotes a random variable of rotten apples, now let's see. In that, if you see this, friends, in that, out of 4 apples, 0 apples can be rotten. If you focus on only, we will be always focusing on only random variable. Now, when we draw 4 apples from that box, what are all the possible cases? 0 apples can be rotten. That means all 4 which we have drawn will be good. Case 2, 1 apple rotten, remaining 3 good. 2 apples rotten, 2 good. 3 rotten, 1 good. All 4 rotten. So this, if x denotes random variable is our number of rotten apples, then x takes all the possible values. Let's say x takes 0, 1, 2, 3, 4. So these are the values taken by our random variable x. Now corresponding to each random variable, corresponding to each value, there will be probability associated to that random variable. Let's say P0, P1, P2, P3, P4. One most important thing that is, which simplifies the complete problem, is sum of the probabilities of a random variable, that is sigma pi, is always equals to 1, friends. P0 plus P1 plus P2 plus P3 and so on, any number of values for the given random variable, sum of their corresponding probabilities will always be equals to 1. If we know this, this gives everything. This gives us everything. Only this value, sum of the probabilities will always be equals to 1. This is regarding probability distribution. Next, binomial distribution. Binomial distribution means this is a specific probability distribution such that in an experiment, the probability, there will be only 2 outcomes. In any experiment, if there are only 2 outcomes, such that, see, we are tossing a coin 10 times. We are tossing a coin 10 times. So number of trials, this n 10 indicates number of trials. Okay, so our experiment is throwing a dice 10 times, throwing a dice 10 times. So n is equals to 10. N denotes number of trials. Now, in each case, I would like to do only 2 particular things. One is, if I get 3, I say I am success. If I won't get 3, condition is failure. Getting 3 is success, not getting 3 is failure. So that means only 2 outcomes I consider. Though I have 1, 2, 3, 4, 5, 6 outcomes, but in binomial distribution, we will be having only 2 outcomes. One is if P denotes probability of success, Q denotes probability of failure. That's it. Okay. So if 3 I get, I'll be successful. If I won't get 3, I won't be successful. Clear? So there will be only 2 outcomes. 2 outcomes. One is P denotes probability of success. Q denotes probability of failure. Now, probability of getting success is, if I get 3, I will be successful. So 1 by 6. Probability of failure is 5 by 6. Now, this P comma Q values are not going to be affected by the number of trials, friends. In any trial you take, in 5th trial or 6th trial or 7th trial, this P comma Q values won't get affected. Probability of getting success in 6th trial will always be 1 by 6 again. In 7th trial, 1 by 6. So, such event where in an experiment such the probability of success or failure does not change with the number of trials, then the probability of getting exactly R success in n trials of such experiment is denoted as NCR into P power R into Q power R minus 1. This is what very important. And sum of the probabilities of failure and success will always be equals to 1. Clear? So the probability of getting R successes in a binomial distribution is NCR into P power R into Q power R minus 1. Why do we named it as binomial? Like in binomial theorem, x plus y whole power n is, general term is NCR into x power n minus R into y power R. No, in the same way, friends, probability of getting R success is NCR into P power R into Q power R minus 1. Next, so this is regarding binomial distribution. Some important results regarding binomial distribution that we have is, one is mean. Mean of any probability distribution is, generally mean means sigma pi. Mean in statistics we have seen sigma fi xi by sigma fi. But here sum of probabilities from probability distribution we have seen it is 1. So sigma pi xi by sigma pi, which is equals to sigma pi xi only. Number 2, variance is sigma pi xi square minus mu square. Here mu denotes mean. Next, standard deviation is square root of this. Square root of this particular value is standard deviation. This is variance and standard deviation. Next, the probability distribution of a binomial theorem X, which we have seen already. For binomial distribution, it is probability of getting R success is NCR into P power R into Q power n minus R. In this binomial distribution, Mean is NP, friends. In binomial distribution, mean is NP and variance is sigma square is equals to NPQ. Probability distribution, binomial distribution. So if P represents success, this formula is called as expectation formula. If P represents a person's chance of any success in venture and M is the sum of the money, they'll give you this. M is the sum of the money which he will receive in case of success. Then his expectation is denoted as P into M. Whenever you find a terminology regarding expectation, we use this formula. Here P denotes success and M is the sum of the amount that which he got if he received that particular success. It is PM. So with that, we are done with complete probability. Now friends, in this lecture, we are done with vectors, 3D and probability. Clear? As per weightage, coming to vectors and 3D, we expect minimum 2 questions and maximum 3 questions even for final exam. For final exam, minimum 2, maximum 3. And weightage wise, if I say difficulty wise, these two, vector and 3D, are the most simplest chapters that we have. Clear? Easiest chapters, as even compared to limits also. More than limits, these two are easiest. Next, the third chapter is probability. In probability, majority of the problems you see the combination of permutations, combinations and probability, friends. So to get good score in probability, we also need good concepts, good strength in concepts from permutations and combinations. Next, last which we have seen total probability and Bayes theorem, which we expect like majority of the years. If you see one question we are expecting from those, make sure you are thorough with it. Last we have seen probability distribution and binomial distribution, also have an idea. Clear? So with that, we are done with this recap 4 lecture. All the very best for your preparation. See you in the next lecture.